everyone. Today we are going to study about what is equivalent focal length and how we calculate the cardinal points for a coaxial lens system. So today's topic is our coaxial lens system for which we will find equivalent focal length and cardinal point. So we will choose a coaxial lens system, then we will calculate the focal length, equivalent focal length and the cardinal points. Alright. Okay, let us consider a lens system. So this is our any lens system. This is our principal axis. We take a convex lens. Suppose an object O is located somewhere here. Alright, these are my incident light. After refraction it will go somewhere here, somewhere at this point. Say this is I dash. If object is behind the lens, say this is L1 of focal length, say F1. Focal length of this lens is F1. So the object is located at point O, so the distance from L to O is U. Alright. So the image is found at I dash, which is V dash. So our image is, if we have an object located at O point, so after refraction the image formed at I dash. See, this is V dash distance away from lens. Alright. If we locate another lens, say here L2, say this is L2, so this is L2 of focal length F2. Alright, so the line converts somewhere here. These line must be convert somewhere here. Say this is the final image obtained from a coaxial lens system, say at I. Alright, we say the final image found at I, which is V distance away from the lens, and the separation between two lenses is D. So we can say that I dash is behaving like an virtual object for lens 2. So the image is found at I. We can say I dash, our I dash is virtual object for lens 2, and the image is formed at I. Alright, so we can say this distance, which distance from lens 2, from L2 to I dash, must be how much? This quantity, this measurement, V dash minus D. I can have V dash minus D. Our whole distance is V dash and the separation between two lenses is D. So we can say the distance from L2 to I dash is V dash D. So this is our ray diagram. So just we will write here, consider two thin lenses L1 and L2 of focal length F1 and f2, say respectively. A point object O is placed at a distance u, which we have already assumed, and object is located at somewhere here in our principal axis, which is a point object at a distance. How much distance? At what distance? At a u distance. So just we are writing at a distance u from the lens L1, or we can say from the first lens, and the final image is formed at I, as we had already mentioned. At I we had obtained our final image, and I dash, which was the image for lens 1, is behaving like a virtual object for lens 2. Alright, so we can say the first image due to the first lens, is formed at IS. Normally we can say a lens system. We had a lens system. An object O is located here, and the image is formed somewhere here. If this is L1 of focal length f1, object O, image formed at somewhere here, I dash. This is our original one, first lens. So we had written what? The first image due to the first lens is at I dash. This we already mentioned. So the formalism for this one is, if this is U and this is V dash, so we can say 1 upon V dash minus 1 upon U is equals to 1 upon F1, if F1 is the focal length for lens 1. Or we can say, if we calculate 1 upon V dash is 1 upon F1 plus 1 upon U, which can be written 1 upon V dash is equals to U plus F1 on taking LCM. This is F1U. Say this is equation number 1. Alright. Now we said if I dash is behaving like a virtual object for L2, if we put L2 here. Alright, so the light will converge somewhere here. Alright, so this is I. So I1 is behaving, what I dash is behaving like virtual object for lens 2, which of focal length f2. Alright, so say the image I dash, which was the original image for lens 1 or first lens, behaves as an object for this virtual here, object virtual for the second lens, therefore the object distance for the second lens is, we had already calculated, this is V dash minus D. Alright, how? This. If this is our virtual object for lens 2, so the U is our V dash minus D. How we calculate it? If original one V dash, the separation between two lenses is D. So the value of U, virtual object distance, is V dash minus D. Alright, and the final image final image is at I. Alright, so we can say final image is V, object is our U, the value of U is now this is our U for second lens. So we will substitute U as V dash minus D, which is equals to focal length for second lens. If now we have to calculate the value of V dash minus D, which is, we take this right hand side, this becomes 1 minus V minus 1 upon F2. Alright, so 1 upon V minus D becomes F2 minus V upon F2. We say equation number 2. Alright, just don't write this equation, otherwise it will create chaos. So finally, if we want to calculate V minus D, so this becomes F2 minus V, F2 minus V. So just we take the reciprocal of this one. Good. Now if we know from equation 1, if we have equation, we can calculate V dash. V dash is our 1 upon U plus F1. We can say, now substitute this value here. Substituting the value of V dash from equation number 1. So V dash is our 1U upon U plus F1 minus of D, which is F2V upon F2 minus V. Alright, in this equation just multiply Y, just to simplify this, or we can take the LCM or a cross multiply. If we need to simplify this equation, just multiplying by U plus F1 and F2 minus V both side. Alright, if we multiply F1U upon U minus F1 plus minus D, and here is equals to F2V upon F2 minus V. Alright, now I said I just multiply here by what thing? U plus F1 F2 minus V. Just write U plus F1 F2 minus V. Just multiply individually both. Okay, multiplying F1, this becomes F1U upon U plus F1, multiply by this U plus F1 F2 minus V, again which is multiplied by D U plus F1 F2 minus V. Now I can cancel this term here, so the right hand side term become 1 upon 2 V. This becomes U plus F1. Good. Now just simplify here. I think this term cancel out, so the final term is F1U. This is F2 minus V minus of D of, just multiply by D inside. So the equation becomes, this becomes du minus of df1 okay, just take negative sign common here, and this becomes here f2 minus v. This becomes f2v u plus f1. Just multiply. The first term becomes f1 f2 u minus, this becomes f1 uv minus of, multiply by just this becomes du f2 negative of df1 f2 negative plus, this becomes duv, and this becomes where this is negative plus, this becomes here df1v, which is equals to f2v u plus f1. All right, now just take it uv common. I have uv here, and uv here. So just I take if uv common, so the first term, this term is positive, so I just write d, and this term is again negative. Okay, just write first u term, so this term is negative, so this is f1, and this, if I'll take it as left hand side, so it becomes again negative, so this becomes f2. Now I take u common. Just see where is u, single u in this term, and okay, in only two terms. So if when I take u common from here, so this becomes f1 f2, and this becomes df2. All right, now just take v common. See where is v, single v here in these two terms. Okay, only two terms. So if we take v common, so the first term is your df1, and this is going to be negative, so this is our f1 f2, and the last term is our this term. Only one left term is this term, so I write it as df1 f2, which is equals to 0. So the final equations comes to be uv in bracket d minus f1 f2 plus u f1 f2 minus d f2 plus v and df1 minus f1 f2 minus d f1 f2 equals to 0. Okay, just to simplify this, I just write it as uv. I take this as a coefficient and write it as a, then this term is a. For my simplification, this term is b. All right, and this term is c, and this term is, just choose another color, so this is my d. All right, just to simplify this, u, this is b plus v, and this is c minus of, okay, take it as, say this is, and d is equals to 0. All right, where all a, b, c and capital D are coefficient. All right, just to simplify, I read uv plus u, I can write b upon a. Just divide this equation. This is the main equation, say this is general equation. B upon a plus v c upon a plus d upon a is equals to 0. So this is a simplification for our generalized equation. Now just there is some assumption. Suppose the focal length of the equivalent of the equivalent length, say our equivalent focal length both of the lengths is capital F, and the reduced object distance and the reduced object distance, although we are taking as for each case is u1 u2, so for generalize we take it as u capital U, which is u minus alpha, and the reduced image distance, reduced image distance, say this is v, which is v minus beta. And now the question is what is alpha and what is beta here. So here alpha represents the distance of the first length from the first principal plane, first principal plane, and whereas beta represents the distance, of the second length of the second length from the second principal plane. Alright, so the generalized formula becomes, length formula becomes 1 upon capital V minus this is 1 upon U, which is equals to 1 upon F. Now we had already assumed 1 upon V is V minus beta minus this becomes U, is U minus alpha, this is equals to 1 upon capital F. Alright, just multiply, we can take the LCM too, but I just simply says multiply by, or we can say multiplying by V minus beta and U minus alpha both side, and say F2, F, this must be capital F, both side. So the equation becomes U minus alpha F minus of V minus beta of F, which is equals to U minus alpha V minus beta. Just simplify this, or we can say that just simplify or rearranging them, we can say UV plus U minus beta minus F plus V minus alpha plus F, just make it this F is capital F, otherwise it is going to be confusing. So this is capital F, this is again capital F, this is beta capital F, and this is capital F plus alpha beta minus beta capital F plus alpha capital F, which is equals to 0. If we see this equation, say this equation is our generalized equation, say x. All right, compare this equation with our generalized equation here. So we can say okay, let me write the generalized equation uv plus u beta upon alpha plus v. If I'm not wrong, this is c upon a plus d. This is our general equation, which is equals to 0. This is our general equation. Now we can compare. I can see this term is this term coefficient. On comparing the coefficient of both the equation, I can say this term is this one, and I can say this is my d. Alright, so this must be d upon a. Just comparing the coefficient, comparing, we will get what? Minus beta capital F is equals to b upon a. Say this is some equation number 6 in general. Right, we will just modify later and say this is alpha plus capital F, which is c upon a. So this is equation number 7. All right, and the last term is your, what is your last term? This is your alpha beta minus beta capital F plus alpha capital F is our d upon a. So this is equation number 8. All right, so we had compared both the equation, generalized equation, with our x equation, and we get to know the value of different coefficient. All right, so these are the coefficient. These are some coefficient, and we say coefficients of our general equation. All right, so we will continue on in our next lecture how we will calculate the value of beta and value of alpha. These are going to be our cardinal points, so we will discuss in our next video. Thank you.